A second example on expectation and variance with probability. You might be presented with a question like this. The random variable x has a probability distribution. The probability x takes any specific value is c divided by x. X can be any number between 1, 2, 3, 4, 5 and 6, and c is some unknown number we've got to find in part A of the question. And then part B, we've got to find the expectation of x, and part C, the variance of x. Well, the first thing to do then is to draw out your probability distribution table in full. List all the values of x, and then all the probabilities that go with it. Now the probability, it says here, is c divided by x. So when x is 1, we get c divided by 1. When x is 2, we get c divided by 2, all the way up to when x is 6, we get c divided by 6. How are you going to find out the value of c? Well, you know that all of those probabilities add up to 1. So the sum of those probabilities adds up to 1. Now you can take c out of there as a common factor. Think back to algebra and factorising. There's a c there in each of those terms. So if you take c out as a common factor, and then if you add up everything that's in the bracket, and then move that to the other side of the equal sign, you'll be left with what c is. And it works out that c is a fraction, it's 20 over 49. And as soon as you got the value of c, what I would do then would be to rewrite your probability distribution without c, but with the numbers in. So this number here was c over 1, c over 2, here I've divided c by 3, c by 4, c by 5 and c by 6. So those are the probabilities, and they do, if you want to check, add up to 1. If you want to, you can cancel those down, make the numbers easier to work with. So part B of the question asked us to find the expectation of x. Well, the formula we had for that was times each probability by the x value and add those up. So here, the sum we all need to do is the first probability, which is 20 over 49, and we times that by the value 1. Then we will take the 10 over 49 probability, times that by the value 2, and add all of those up. And if you do that, you should get, you can check it yourself, 120 over 49, leaving it there as a top-heavy fraction. For the variance, well, the formula we had for the variance was the expectation of x squared, take away the expectation of x squared, and that was timesing each probability by the square of x, each x value. Well, that's the expectation of x squared bit, and add those up, and then take away what we've already worked out, squared. So the expectation of x squared would be 20 over 49 times by 1 squared, plus 10 over 49 times by 2 squared, and so on. And then I have to take away the expectation of x all squared. So you've got on screen at the moment the calculation for the first bit of that formula, the expectation of x squared. If you work that out as a fraction, that comes to be 60 over 7. The expectation of x that we had earlier was 120 over 49. So for part C, the final bit of that one, working out the variance, that's the formula we're going for. So I think we've seen some of this already. Substitute the values into the formula and you'll get a number out. Got it here as a decimal number. But the process there, it's just using the formula, the expectation of x formula, the variance of x formula. Once you have your probability distribution, then you'll be okay. The next video is going to look at how we work out the expectation and the variance for specific distributions, for the binomial distribution and for the geometric distribution, and that will be in part 3.